is not a very bright machine. It only does addition and multiplication. It doesn't really know what the sine of 1 is. So what your calculator does is it thinks the sine of any angle, x, as nothing more than an x minus a 1 over 3 factorial x cubed plus a 1 over 5 factorial x to the 5th minus a 1 over 7 factorial x to the 7th plus et cetera, et cetera, et cetera.
I think it's a pretty smart machine.
There's an infinite series. I'm sorry, I'm speaking too fast. There are infinitely many terms over here that I add together to get exactly what the sine of x is. Now your computer, your calculator is not going to do this. It's going to say, well, out to a certain point I'll stop because then I've got my desired accuracy. But then now when it plugs 1 in for x, it can get a darn good approximation for the sine of 1 radian. You and I next semester, you will in your Math 31 class derive all these out of thin air, so you believe they're true, and exploit them to do some really nice approximations. Well, yeah, you're not going to use all infinitely many terms, just a finite number.
Super excited.
Oh, you should. You guys, it's pretty picture time. Let me consider this value of x right here. I'll call it A. And if I use this value of x to go straight up the curve and draw a tangent line, I think the tangent line looks like this. Oh, come on, that was a brand new red pen. And if I moved over a certain distance to the right, how about the, I like that upper Greek letter delta for distance.
Okay.
So how about moving over to the right delta x?
Is there an epsilon in there as well?
No, not this time, not this time. But that plants me right here, which is located at.
A plus delta x.
Oh, I didn't go far enough with my tangent line. Hold on. And now if I went straight up to my curve again, I want a yes or no answer. Is the location of that point going to be a plus delta x, comma f of a plus delta x? And if I were to draw in a nifty little right triangle, wouldn't that be it? But you guys, if I actually plant my feet right back here on the curve located at the point a comma f of a, I move delta units to the right and move them vertically up to the new position on a tangent line. Is this going to be the same as a delta x? Oh shoot, you're right, it's not. Can I change my letter notation? I might think of this vertical deviation as maybe a dx, and it's merely an approximation for delta x. And I would think of the horizontal length right here also. Did I misspoke, you guys? I'm sorry, I didn't mean dx, I meant dy. dy, my apologies. And I don't think that's equal to delta y, which is going to be this vertical deviation. But it'll certainly be an approximation for it. I like to use the word, the letter delta to identify a change in the actual curve itself. I'll use d's, or our alphabet d's, to represent a change in terms of tangent lines. By the way, you guys, if I'm going to use this dy notation, I guess I better refer to this horizontal deviation as dx. It's just that in my picture, you have to agree that dx and delta x, they really are the same. Agreed? So, you guys hear me. I think that if for whatever reason I might have, if I were to try to evaluate that to a plus delta x, yes or no, can I interpret it this way? As nothing more than the y value of the point at a comma f of a, increased by a certain amount that I'll refer to as a small change in y. Well, look at my picture. Does that sound accurate? Well, I think it was most definitely. Most definitely because of this. Here's a vertical distance f of a. And if I add delta y to it, that really does get me up to the y value f of a plus delta x. However, I don't think that these are equal to each other. I think the second is merely an approximation for the sum you see upstairs.
So,
yes?
you're saying that dy is an approximation of that distance and change in y is actually the distance?
Yeah, so I think this is the actual change in the vertical distance from one point to another on the curve, but this d at y is nothing more than an approximation for it. And if you guys take a peek at my picture, what could you possibly say about f prime of a? In terms of my picture.
It's going to be
You're right, it is. What else does it represent?
The point of tangency? With the
No, I
tangent?
think it's a number. I think the point of tangency is a comma f of a.
Okay.
So I think f prime of a is the slope of the red line. And if it's the slope of the red line, don't you guys also agree that the slope could be interpreted as a ratio of rise to run? So don't you guys agree that the f prime of a can be interpreted as the ratio of the amount of rise to the amount of run? To go from one point to another on the red tangent line? Oh, but you guys, don't mistake this. I'm not talking about the derivative with respect to x. I'm talking about a ratio of distances. And as a matter of fact, if I multiply both sides by dx, doesn't that tell me dy is nothing more than f prime of a times that small change in the x direction? And so I think another name for the second term over here, my approximation, is simply going to be my f prime of a times dx. You know what? This is a good time to take a break. Not to prove anything, but to make a man-made definition. So definition. Let f be differentiable at x equals a. The independent and dependent differentials dx and dy respectively are defined as follows. Namely that when it comes to that dependent differential I refer to as dy, it's nothing more than the product of my independent differential dx times the derivative of my function at a given value of x that I labeled a. It's just a man-made definition, and you have to confess it's kind of nice how if I do divide both sides by dx, that ratio is just nothing more than that prime of a, the slope of my tangent line. And I think using this differential in this fashion is going to allow you and I to make some pretty darn decent approximations. You guys, I know I'm late. I know we need to take a break. But I've introduced this. I hate to take a break without showing it its usefulness. So can I?
Please.
Are you ready? Because I think when it comes to the square root of 51, this is nothing more than the square root of, I don't know, how about a nearby perfect square like 49? Increased by 2. And I think this is nothing more than the square root of 49 plus a small change in the y direction. I just think it's too difficult to calculate. I'm going to cheat. I'm going to use differentials to approximate this. And so I'm going to rewrite this as approximately equal to root 49 plus f prime of my 49 times a small change in the x direction. Where? You guys help me with this. My original function in x is nothing more than which function? Well, if this is f of a, clearly f of x is,
Square root of 51.
well, I think just the square root of x. That's clearly the function I'm approximating. If this term right here is supposed to be my f of a in the middle board, then that's going to, my function f is going to be the square root function. And I also think it's derivative function you and I can generate off the top of our heads in our deep, deep, deep REM sleep. If that being the case, I maintain that what I have sitting in front of me is the square root of 49 plus 1 over 2 times the square root of 49 times a small deviation in the x direction, but that's just simply 2 units. But that means I'm merely left with a 7 and 1/7. Holy cow, you guys. I just came up with a decent approximation for the square root of 51.
Where did you get the multiplying by 2 after the fraction?
This 2 came from the value of what you see circled in green right here. It was just a small deviation I had in the x direction.
How do we know that that was like?
Because it's right there. Now, I admit, I've got a delta x over here, but delta x and dx are the same. They're interchangeable, not the delta y and dy are. It certainly is with the x's. You know, you guys, I'm nervous. Do you think I can do this really quick? Let me pull out my nifty little calculator. Let me quit this particular cell, clear this all out as well. And let me go ahead and compute, I can't read it. Is it 7 plus 1 7? Oh, there it is. However, the square root of 51. Shoot, you guys look at that. These two agree up to the second decimal place. They only deviate by 1 unit in the third decimal place. That's pretty darn good accuracy. Don't you agree?
Yes.
So,
It's crazy. It's
this
beautiful.
can drive me insane, but can you put in the plus sign there so we know that it's 7
Yeah,
plus 1
which
7?
plus sign? Where?
So I didn't know that's 7 plus 1
Oh, yeah, I was writing as a mixed.
7. Alright.
Yeah, it's very ambiguous notation. You guys, 10 minutes?
Sure.
Sorry to shove it down your throat. I just felt like doing something for you.